Hello, everyone, and welcome to our webinar today, where we'll be talking about trusted application delivery using GitOps and policy as code. Before we begin, I'd like to mention a few points. Today's webinar is being recorded, and we'll share this with you later today. All participants are in listen-only mode, so if you'd like to ask a question, and we do encourage them, please use the Q&A panel, which is on the bottom of your Zoom menu, and we'll address those at the end during the Q&A section. I'd like to introduce you to our speaker today, Steve Waterworth, who's our Technical Marketing Manager. Steve's been in technical roles in the app performance management space since 2004, where he's seen numerous technical revolutions and market disruptions, giving him a unique insight into the rapidly changing DevOps environment. And now I'll hand you over to Steve to begin. Thank you.
Good morning, all. Oops, don't click too many. So welcome to the webinar. So let's get started. First of all, for those of you that don't know about Weaveworks, a little bit of background. We have customers across many verticals, and we are key partners with all the major cloud providers. We both contribute and maintain a number of open source projects, and we're backed by a broad range of solid investors. So let's move on. So building better code faster is really what's driving modern organizations. You know, the faster you can get new features and fixes out the door, the better, because if you're not doing it, your competitors are. But there's a bit of a paradox with that, because the faster you go, the greater chance there is of making a mistake. And of course, what we want to do is go fast without breaking things. So let's look at that in more detail. So this is really where that paradox is. You know, we're doing agile development, we're using containers, we're doing all of this to get that speed. But as we say, the faster you go, the more danger there is that you can trip up and fall flat on your face. You know, automation's great, but it's indiscriminate. So it will automatically deploy good stuff, and it will also automatically deploy bad stuff. So how do we manage that? And this is really where that policy as code or trusted delivery comes in that we can put in additional automated checks as part of that GitOps workflow. So if we have a look at a typical GitOps type workflow, we have a DevOps engineer. They create the application. They may use the Weaveworks GitOps UI, or they may do it entirely manually in their favorite text editor. Anyway, what you end up with, of course, is a pull request that goes into the management repo, and it goes through the usual pull request approvals, gets peer reviewed. But the problem is that pull request could be several hundred lines of YAML, and humans don't do a very good job of reviewing that. So, you know, mistakes can get through. So there could be, bad configuration can get through, might not necessarily be caught. As we said, bad configuration will get deployed instantly, just as well as good configuration, because if we get bad configuration out there, then that could give us problems on our cluster or our application. We may have some security problems, some stability problems, which of course we don't want to do. So using policy as code, that provides additional automated checks, and they really focus on three main areas around security. So are we just using containers from approved registries? Do we have any containers running privilege or root that don't need that level of privilege? And then around resilience, are the health probes defined properly? Have resource limits been set? Is there a minimum number of replicas? All those types of things. Is that application, is that deployment well configured? And then finally, coding standards. Every organization has their own standards for annotation and labels to make the ongoing maintenance and management of applications easier. So again, we can check that those annotations and labels are there, and that the values they're set to are same. And those checks can happen at multiple places. At commit time, So if we can then pick that up as part of the PR, so straight away when you go to review that PR, you'll see that there are violations. It can also happen at build time. We integrate in with continuous integration tools like Circle CI. So when that automatic build is triggered, policy checks can be performed and the build fail if there are violations. Then ultimately, the ultimate backstop is the Kubernetes admission controller. So even if you try and circumvent all the other checks and balances and sneakily go in and do a kubectl apply of something that's really not good, the admission controller is going to stop that and it's not going to get deployed. And then finally, at runtime, so there's an agent that goes on the cluster, which is continuously checking and reporting back. So that was sort of the use case there is, well, for existing clusters where you already haven't got policies code checking the deployments, but also then as you update the policies, you may update a policy and something that was previously deployed is now in violation. So that continuous runtime checking will capture those use cases. So we look now then at that workflow. So the good news is, from as far as the DevOps engineer is concerned, nothing changes. They're just doing their regular workflow with Git. They're creating that pull request. It goes into the management repo, but this time, as well as being peer reviewed, policy as code kicks in and also reviews those few hundred lines of YAML. So the chance of getting good code and good configuration out into the cluster is much higher. If you look at the DORA State of DevOps reports, the elite performers there only have a 15% or less error rate on change. So doing those automatic checks is certainly going to significantly improve those figures and get you down to doing perfect releases every time and having happy applications on a happy cluster. So let's just drill into some of the benefits then of using policy as code and doing those automatic checks. So first of all, it's seamlessly integrated. Your DevOps engineers, they've got nothing new to learn, no new dialogues to log into, things to get access to. It's all part of that regular GitOps, Git PR workflow. Checks are all automatic. It all just happens. Really low level cost of entry there. Comes with a comprehensive library. There's over 100 policies already baked in, and that library is curated. We're updating and tweaking those as legislation changes. And it's covering the main industry standards, as well as other things that are just generally a good idea. It's built on Open Policy Agent and uses the Rego language. So very easy to update and create your own policies should you want to. Using GitOps gives you enhanced security, and then of course adding policy and code on top of that, it gives you even more security. So we've got, as we said, we've got that auditing and reporting across the fleet of clusters. You ultimately have that ultimate backstop, that admission controller that's not going to let anything through. And because you're using because it's all part of that GitOps workflow, then the number of users that need direct access to Kubernetes is greatly reduced because everything's done through Git. It's really only the cluster admins that will be doing anything connecting directly to Kubernetes. So you're not spreading Kubernetes and cloud keys around the place. And of course, GitOps gives you that zero configuration drift because that constant reconciliation of GitOps. You can guarantee that what you've got defined in Git is what is actually running in your cluster. It's going to improve application resilience because, again, those policies will apply. And I'm sure we've all done it. I certainly have. You write a deployment manifest or something and make one tiny little typo or miss something off, and you end up with something that is maybe not as resilient as it should be. Policies code is going to kick in and double check that for you. The chance of getting bad configuration through or something that's non-optimal is significantly reduced. And then finally, we're going to be able to apply those coding standards to make sure everything's properly tagged and labeled. Because if it isn't, then it makes the management, ongoing maintenance, so much more difficult because you can't find things if they're not correctly tagged and labeled. So those coding standards can be double checked. And again, stuff will not get deployed if it violates those coding policies. So having done all of that, time for a quick demo. Hopefully the demo gods will smile at me this morning. So let's have a little look at the demo. So what we have here is a deployment manifest, and you can see we have 2 replicas defined. Now, actually, what I will do before we fly into that, let's start with a little bit of background information. So here's the Magalix dashboard, and this gives us a top-level view across our entire fleet of clusters. This is a demo environment, so I've only got the one, but if you have multiple clusters, they'll appear here, and the top-level report will be across your entire fleet. So this is that continuous runtime auditing and reporting. You can drill into individual clusters and then see the detail of the violations within the individual clusters. There is a library of policies. So this is what ships straight out the box. This gets you started. This covers a wide variety of both industry standard and other things that are just generally a good idea, like not putting the MySQL password in an environment file and actually referencing it properly through, and other things like minimum replicas, containers running as root, all those types of things, all out the box in that library, and which of course you can then tweak and tune and enhance by writing your own. You can run regular reports, so there's various reports straight out the box. Again, you can run those reports, and of course you can build your own reports. And KubeGuard, this is what does the runtime checking. So KubeGuard will check against policies. So if we take a look at this resilience one, this is the one we're going to be using in the demo. It's very simple. Keep it simple for the demo. It's just going to check that there's a minimum replica count for the container. Then finally, we have Kube Notifier here. So this is allows you to integrate in and get notifications via numerous channels when there's a problem. So if this is part of that continuous scanning, so if you suddenly get a bunch of vulnerabilities appearing or a bunch of violations appearing in your fleet, you're going to get notified about that. So let's just go through that KubeGuard workflow, and we're going to make a change. KubeGuard's going to block us, and we're going to go through that and try and fix it. So as I said, I was in my code editor, and here we have our replicas of 2, which is currently within policy. This is already applied. So if I go out of policy and bump my replicas down and save that, then we'll see here where we've made that change. So I can add that change and commit it. So that's push my change across, and then over here I have my Git repo. This is coming off, and hopefully this hasn't picked up my pull request. I've got the demo branch. Okay. Why didn't that pick up my pull request? The demo gods are not smiling at me. So I want to pull demo into main. I'm going to create my pull request. Okay, cool. I don't know why that didn't kick off automatically. So through the GitHub actions, we're now automatically running those checks, doing this code scanning. So this pull request is just being scanned, just ticking along. It always seems to take a long time when you're waiting for it in real time. So, and as we can see, it has failed. So this is doing the check. And if we take a look at that report, you can see here, it tells you why it's failed, gives you some explanation, gives you links back to the policy. So you've got all the information you need. It's not just this has failed. It gives you plenty of context around that. And because it's something simple, like pull requests, like replicas, we've got, we can quite easily remedy that because we know we need at least 2 replicas. If it was something like a health probe, very difficult to auto fix that because we don't necessarily know what the health probe is going to be. But with something simple like this, we can do that. We can do an auto remediation. So if we then take a look here, it's actually created as another pull request off that with the fix already in that. And if we go to the files changed here, you can see I tried to put in 1 replica, it's rejected it, created the pull request, and has fixed it to 2 replicas. Cool. So that's so we've got the 2 replicas there. And now I could just merge that in and we'd be good to go. But I want to do a little more with that. I'm going to tweak this. And rather than just have the 2 replicas, I'm going to go big. We're going to have 4 replicas. And we'll commit those changes into that. So now we've got our 4 replicas there. Back to our conversation. So that's good. We can then merge that pull request in, confirm that merge. So that's good. That's all good. Back to our pull request. This is our scale down pull request. And of course, it will rerun those checks. It always seems to take a while when you're sitting in live in a demo waiting for it to happen. But of course, it should pass this time because of course 4 is greater than 2. Not a problem. There we go. So that's all merged in. It's being checked. We don't have any violations. So I can now merge that into main, and the GitOps process will kick off. So if I take a little look, so currently this is my Kubernetes cluster. I have my pod info app, and I currently have the 2 replicas. So if we go back to Git, and we'll merge that pull request in, confirm that merge. So that's merged that in now. And if we go back to looking at our Kubernetes cluster, again, we're just waiting for that constant reconciliation to kick in. And it should any moment now notice there we go. So we made the change to Git. We said we wanted 4 replicas. GitOps reconciliation kicks in and we get our 4 replicas running in Kubernetes. So hopefully you can see that we tried to make a change that was outside of policy. That was picked up straight away as part of that PR process. So we had that red flag straight away. We could review what it was. It told us plenty of information, gave us context around the violation. We could then fix that, merge into main, GitOps reconciliation kicks in, and we have our 4 replicas running live in our Kubernetes cluster. So demo gods smiled at me today. One thing we could do actually, if we go back to our Visual Studio Code, so this is what I've got locally on my machine. We've still, because I haven't done the Git pull to resynchronize. So locally on my machine, it still says 1 replica. So if I try to cheat and do a kube ctl apply. This is a customization, so I'm going to apply the current directory customization. So I'm going to try and get that one replica live, and boom, the admission controller kicks in straight away. There's our admission webhook, and it's saying, no, you can't do it because you don't have enough replicas. So that's the ultimate backstop. Even if you try and cheat the system, it's not going to let you because that admission controller stops you. So that's the end of the demo. We shall pop back and go back to the presentation. So now we're at the Q&A stage. Hopefully you guys have been, whilst I've been chatting, have been busy typing questions into the Q&A box, and now we'll take those questions.
Great. So we have one from Pravesh. Do more and more policies in different pipeline steps slow down the complete CI/CD process?
Not really, because the one KubeGuard can have many policies. So you're just calling the KubeGuard once. Obviously, as you saw, there's a bit of overhead with the GitHub actions. It does take a little while for the container to spin up, everything to happen. But yeah, you can see I could do that live, and it's just a few seconds. So you could have a KubeGuard with many policies, and really the difference in speed is probably milliseconds. You're not going to notice it.
Brilliant. Another question, how does Magalix integrate with something like Circle CI?
So essentially, it's just like the GitHub actions. Essentially, what's happening in the background is with the Docker container gets spun up, it gets the KubeGuard webhook passed into it, which it calls and returns a status. So really, any CI tool that you can script, which I'm pretty sure is all of them, that you can put that call in to KubeGuard. So you can do it obviously in Circle CI, Jenkins, GitHub Actions, Google Cloud Build, loads of them. Yeah, it's all quite easy to do. It's in the docs.
Great. Are the standard policies kept up to date?
Yeah, so it's a curated list of policies. So we're constantly keeping an eye on the various standards as they get revised, and also not just the industry standards, but just general best practice for managing your Kubernetes environment. So yeah, those policies are constantly kept up to date.
All right. What Kubernetes entities can the policies be run against?
Against any Kubernetes entities. So obviously the standard ones go against sort of deployments and pods, etc. But if you've got some CRDs that you want to have checked by policies, then you can do that. As part of a policy definition, one of the fields it takes is a kind target. So basically a set of kinds this policy will be run against. So yeah, any kind you can put in there if you've got custom resource definitions.
Great. Why would I use Magalix instead of another solution like an OPA gatekeeper?
So yeah, Magalix is more of a complete solution. So first of all, as we've just said, there's the curated library of policies that's kept up to date. There's the dashboard that comes with it. So you've got that ability to quickly see policy violations across your entire fleet. There's the reporting, there's the admission controller. So it's a much more complete package than some of the open source offerings that are out there.
Great. What else is there? When will Magalix be available via Flux and Weave GitOps?
So as you saw, we already, during the demo, we were using Magalix and Weave GitOps together. So we only recently acquired Magalix, and our engineers are currently working as we speak on a much tighter integration. So yeah, coming soon, that'll be much more closely integrated, and you'll be able to do all your policy management as code, basically through Git. The policies will be stored in Git. So if you got that standard GitOps workflow, if you update a policy in Git, then that policy is updated across your entire fleet of clusters. Expect some announcements around that soon. That's all I can say at the moment.
Great. So how can I play with this now?
Good question. So let me just go to the next slide. So you can go to Weaveworks /core and download Weaveworks core for free. So that's what I was using today. I was just using the core version for the purposes of the demo. You can go to magalix.com, and top right on that homepage is a free trial. And that gives you full access to Magalix for a time-limited period.
Great. I don't see any more questions at the moment. Anyone have any other questions you'd like to ask?
Speak now, forever hold your peace.
Of course, we will be sending this recording afterwards and the slides. So if there are any questions that crop up later, you're more than welcome to get in touch with us and we can talk further. Okay, let me just double check the chat. No. Q&A. No. I think we're good.
Okay, guys, if you get a little bit of time back, go grab yourself a cup of coffee and have a good morning.
Thank you, Steve. That was good. And thank you, everyone, for joining. Until next time, goodbye.
Okay, bye.